Okay, here we go with question 5a, and it starts off, it talks about a student who's holding a golf ball and a table tennis ball out of an upper window of a tall building. The balls are released at the same time, both balls have the same size, and the golf ball has a greater mass than the tennis ball. One of the balls reaches a greater terminal velocity. And the first part is a state and explain the acceleration of the golf ball immediately after it is released. Okay, well, as hopefully you all know, everything, if it's in free fall, will have an acceleration of free fall. So I would state the acceleration would be 9.81. Don't forget to put the units in, meters per second squared, and explain, well, everything has the acceleration of free fall in a vacuum because there's no drag force, and of course the only time when, if you're not in a vacuum and there is some air resistance, that you don't have any drag force, that is because it's not moving. So at this point the drag force is zero. Right, now we're on to the second part. By referring to the forces acting on the golf ball, explain what is meant by terminal velocity. Okay, so the golf ball will be at terminal velocity when the drag is equal to the weight. And this is only a single mark question, but obviously if we just have a little diagram here, if I've got the weight acting down and I've got the drag acting up, if they're equal to each other, therefore the net force is zero. So the terminal velocity, if you've got a net force of zero, the terminal velocity is reached because there's no longer an acceleration, because there's no force there ready to cause the acceleration. And that leads us nicely into the third part of part A. Explain which of the two balls reaches the greater terminal velocity. I would say, well, the golf ball, although there's not a state and explain, but I would state that the golf ball reaches the greater terminal velocity. And we've got to explain why. Okay, this is because it has a greater mass. And hence it has a greater weight. And therefore, because the drag force is proportional to the velocity squared, you need a greater speed for the drag force to equal the weight. So now we're moving on to part B, and you're presented with this graph, and as with all graphs, first thing you need to check are what are the axes. So we've got the velocity here, and it's in meters per second, and we've got the drag force D, and they are trying to put a little slip in by giving the units as being kilonewtons. Okay, let's see what we've got to do. So the lorry has got a mass of 8,000 kilograms. Its engine provides a constant forward force of 3,200 newtons, and we're asked to calculate the instantaneous acceleration of the lorry when travelling on a level road at a speed of 25 meters per second. Okay, let's just have a little little diagram. So here's my lorry. We've got a constant forward force here of 3,200 newtons, but as we've shown in the previous question, the previous parts of the question, there is a drag force, and that drag force depends on how fast the lorry is going. So our lorry here is going in at 25 meters per second, so if we're travelling at 25 meters per second, that gives us a drag force of 2 kilonewtons. So let's just get my pen. 2 kilonewtons is 2,000 newtons there. And we're going to be using F is equal to ma, but as always the F in this equation is the resultant force, and it's the resultant force of these two forces here. So if we combine those two forces, that's going to give me 3,200 minus 2,000. That gives me that F is equal to 1,200 newtons. So if I put that into our equation, well, let's rearrange it. So the acceleration is equal to F over m. So I've now got equaling to 1,200 divided by the mass, which is 8,000 kilograms, and that gives us an acceleration of 0.15 meters per second squared. And now we've got to explain why this lorry cannot travel at a speed of 40 meters per second on a level road. Okay, so I've put the graph in to this bit as well because you need to know that. So let's have a look. If it was travelling at 40 meters per second, then it would have a drag force of around about 5,000 newtons. And if we remember from the previous question, the end provides a constant force of 3,200, so because there's no gravity to help it, then the drag force is greater than the forward force. So let's just write that down. So at 40 meters per second, the drag force is greater than the force of the engine. And the final part, part C to this question, is asking us about the lorry driver wearing a seatbelt. Describe and explain how a seatbelt reduces the forces on a driver during the impact in an accident. The reason it happens is because the seatbelt stretches, which increases the time taken to come to a stop. And if we increase the time taken, obviously we've still got the same change in velocity, but divided by time, that is equal to our acceleration. So we've always got the same change of acceleration, but if we've increased the time, we've lowered the acceleration. And because F equals ma, a lower acceleration means a smaller force.